Hi guys, welcome to week number 5. This video will give you two examples, one of completing the square and a quadratic, and then one using the quadratic formula. And each of them we will go and check our answers graphically so that you can see both ways to do it. Okay, so this one we're going to use completing the square. In this section you're also going through solving by factoring, but most of that will be review for you. So when I start to solve a quadratic, I'm really trying to find the roots or the x-intercepts or the x's that make this true. And I'm going to do it by completing the square. So similar to what you did last week, but last week had two variables in it. So this is even a little bit easier. So the first thing we're going to do with this one, we've got 2x squared minus 8x equals 7. So if I want to complete the square, this value right here has to be a 1. There's no way I can complete the square and make it a perfect square trinomial unless that it's a 1. So since it's not, I'm going to divide out of 2. Whether it goes evenly or not, I have to divide it out. So I end up getting x squared minus 4x equals, and I'm going to leave that as 7 halves. It's easier to leave a fraction when we get, because this is going to be under a radical soon, it's easier to have it in fraction form rather than a decimal. So remember, my goal is still to be able to, I'm going to put this kind of up on the side here. My goal in completing the square is to get a quantity squared. Okay, so x squared minus 4x, even if I brought that 7 halves over, it's still not a perfect square trinomial. So this is where we put in these blanks and we figure out what has to be there in order to make this a perfect square trinomial. So remember, in a second, this is going to factor into like that. So we take the 4, we cut it in half and get a 2, and then we square it and get a 4. So this is kind of one of those special examples where both of those 4s are matching. That doesn't usually happen. And then if I add 4 on the left, I have to add 4 on the right. And now over here, what we have right here is a nice perfect square trinomial that can factor into x minus 2 quantity squared. Okay, so that was our goal. And then over here we just have to do 7 halves plus 4, so that's really 7 halves plus 8 halves. So I end up getting 15 halves. I'm going to leave it like that. Okay, so now that is what I wanted. I really did complete the square, and now I'm going to solve it. So I'm going to come up here. Okay, I've got x minus 2 quantity squared. And at this point, I'm done completing the square, and I'm going to solve it by using the square root property. If I have a quantity squared, I can square root both sides, but I want to make sure I use plus or minus so that I get both roots. So I end up getting x minus 2 equals plus or minus square root of 15 over 2. Now some books don't accept a 15 over 2 under a radical. Just from looking through your textbook, this one does. But some books have you rationalize and get the 2 out of the radical by multiplying by radical 2 over radical 2. But you shouldn't have to do that, because from this book, they're not having you do that. So the only thing I really have to do now is bring the 2 over to get x by itself. So I get 2 plus or minus radical 15 over 2. So my two values, if I had to separate them, I'd say my solution set is 2 minus radical 15 over 2. And 2 plus radical 15. Oh, sorry, I'm squeezing that in there. Those would be my two roots. So let's say that I wanted to make sure that, so if I were trying to check this, what I would do is bring the 7 over and get it into all on one side so I could graph that parabola. Okay, so that parabola is opening up. If you graph it on the calculator, this is really just kind of a rough sketch. It would have a y-intercept of negative 7. So it would look something like this. Again, like this is just a rough sketch. And if you went on the calculator and you found the zeros, you found this one right here using the zeros and this one right here, you would end up seeing that this one right here is 2 minus radical 15 over 2, whatever that is as a decimal. You'd have to actually do it out and see what the decimal form of that is. But those would be our roots. These are both real roots because you see it does cross the x-axis twice. Okay, so we end up with 2 real roots. You're going to see next week when we start doing imaginary roots that sometimes the graph does not cross the y-axis. The x-axis. You'll see that a little bit this week, but you won't solve any where you have to use that imaginary number until next week. But you will start talking about what happens if the discriminant is negative and that ends up being no real roots. Okay, so you can check all these by finding the intercepts on the calculator. Okay, so this one I'm going to do using quadratic formula, and I picked one that wasn't factorable. All right, so solving using quadratic formula. So if I could divide anything out, I would, and not that I have to, but just to make my numbers smaller and easier to work with. But nothing goes into all three of these, so I'm just going to leave everything like it is. Everything's already on one side, so that part is done for me. If something was on the right, I would move it over and put it in the right order. So I'm going to start picking out what my A and my B and my C are. A is 3, B is -6, and C is 2. So my quadratic formula tells me that the roots, the x values for this, are going to be opposite of B plus or minus square root of B squared minus 4AC all over 2A. Alright, so let's plug them in. So opposite of B would be the opposite of -6, so it would be 6 plus or minus. Let's see what we have in this square root. We have -6 squared minus 4 times 3 times 2 all over 2 times 3. Okay, let's keep going with now we're just really simplifying. It's already solved for x now. We're just finding our roots in simplest form. So let's see what we have underneath here. We have 36, okay, minus 4 times 3 times 2. So we end up with minus 24 over 6. Okay, so if the A or C is negative, we end up having plus a 4AC. Not that the formula changes, but if A or C is negative, that ends up being a positive sign. Okay, so let's keep going. We have 6 plus or minus square root of 12 all over 6. All right, so it's so tempting, and people always want to divide out these 6's and cross them out right now. But I can't unless there were a 6 in front of that radical. Okay, and I can't divide a whole number into a square root. So what I end up doing, I'm going to come down here. Okay, I'm going to keep simplifying and come down here. I am going to simplify that radical 12 into, well, radical 12 can simplify to radical 4, radical 3. So that would become 2 radical 3 all over 6. So the best I can do is I can reduce a little bit, not by 6, but I can reduce everything by a 2, which means the 6 will become a 3, the 2 will become a 1, so I just have radical 3, and this becomes a 3. So that's one acceptable answer. Sometimes my math lab wants it like that. Sometimes it wants you to separate it and now bring the 3 into each one and say, okay, 3 goes into, so they're having you write it like this sometimes. This is where it can sometimes get tricky. Usually, I mean, if you were taking this in a class with me, I would say right there is absolutely fine. But if it wants you to separate into 2 ones, then do what I'm doing over here and keep going and say 1 plus or minus radical 3 over 3. Okay, so you have to just kind of, I know it's frustrating with sometimes the different notations of how to write your answer, but just kind of bear with my math lab. There are a lot of great things it has to offer, and I kind of think the benefits outweigh some of these kind of glitches with, the form of your answer. But just know either one of them are right. If you're taking a paper test, either one of them would be accepted. All right, so last thing we're going to do with this is let's just kind of, I wanted to kind of point out as we went, I forgot to do this before, but when we were up here where we had the radical, and we had a square root of 12, so the 12 is what we call our discriminant, and that came out positive. So this should have 2 real roots. Okay, if our discriminant is negative, that means it's not going to cross the x-axis. We don't have any real roots. You're just going to do it on the calculator. I'm just giving you a quick little sketch to show you what it looks like. And it's going to be, it does have a y-intercept of 2, and it comes down and back up if you check it on your calculator. So there's going to be one root right there. If you figure out what the decimal for that 1 plus or minus radical 3 over 3 was, this should be the larger one right here, the 1 plus that, and this one will be the 1 minus square root of 3 over 3. So you can see when you graph it, you do get two real roots, and that's because the discriminant, that d equals, and that's just the number under the radical, happened to be greater than 0. Okay, so hopefully that helps you with a couple examples this week, and don't hesitate to ask if you need some other ones done out. Have a good week.